So on number 6, we have an exponential equation. It's not a logarithmic, it's an exponential. And what do we like on exponential equations? We like the bases to be the same in order to just cancel out the bases. That way the exponents could come down and be the actual equation. So in other words, I have a base 10 here. I would love this 1/100th to look like a 10. Could I do that? Could I change the 1/100th to look like a 10? Absolutely. Let me redo my parentheses here. Let me redo the 6x minus 1. But instead, or that's not a minus. There you go. That's ugly. You guys know what I'm talking about. 6x minus 1 out there. But the 1/100th, I could rewrite it as 10 to what? 10 to the negative 2 power. Man, I'm struggling with the negatives. 10 to the negative 2 power. So now I really do have a 10 over here to the 3x minus 10, and I have a 10 to the negative 2 to the 6x minus 1. So keep in mind that a power to a power, you multiply, so you have to take the negative 2 and distribute, make it negative 2 times 6x, that's negative 12x, and negative 2 times negative 1 is positive 2. So let me rewrite this thing one more time. So there we have our rewritten equation. Again, negative 2 times 6x is negative 12x. Negative 2 times negative 1 is positive 2. And now that I have the same base 10, now I could apply a log base 10 or a common log to both of these sides of the equation, which means that these guys cancel out and the above is your new equation. So we really have 3x minus 10 equals negative 12x plus 2. And I don't know, but if you see it, I wrote it up here. Okay. So let me now solve this equation. I'm going to add 12x to both sides, and I will get 15x, and minus 10 equals 2. And if I add 10 to both sides, let me just not show my work, I'll get 15x equals 12 if I add 10 to both sides. For my final step, I'm going to divide by 15. And divide by 15. So I actually get my answer, x equals 12 over 15. But you could reduce that by 3, and you'll get 3/5 as a final answer for x. You got it? I'm just kidding. It's not 3/5, it's 4/5. If you reduce by 3. 12 divided by 3 is 4. 15 divided by 3 is 5. So yes, 4/5 is the answer. I apologize. Wrong answer. Let's move on to the real fun stuff. Number 7 and 8. These guys are a totally different beast right here. What's the first thing that comes to mind? You want to solve for x. Justin, what do you do? Okay, if we could get bases to be the same, we would. However, 33, you can't rewrite it as 11 to a certain power, right? So that's a good first step to try to think and see if you could change 11 to make it look like 33 or 33 to look like 11. You just can't do it. So bottom line is I want to solve for x. X is an exponent. I don't want it to be an exponent. Both of you. So how do I get that x to come down? Anybody? You're going to apply a log base 11 to both of these guys. So log base 11 of 11 cancels out. You're going to have a new equation that says 5x equals log base 11 of 33. Are you with me? Now, of course, you're probably not going to have enough space to write it down on that piece of paper. Hopefully you do. You probably won't, though. So you probably want to do this on a separate sheet of paper. Because I still need to solve for x. What do I do next? Divide by 5. And divide this whole thing by 5. So far, so good? Now, here is the problem. The problem is that I have my answer written as x equals log base 11 of 33 over 5. And you want to be able to identify what the actual value of x is, like as a decimal. So how the heck am I going to find out what log base 11 of 33 is? The calculator doesn't do base 11. you're going to have to apply the change of base formula, guys, and either use ln button or common log button. So we're going to focus in on this part right here, and we're going to use a change of base formula, which is going to give us a fraction. And on top, you're going to have common log 33, and on the bottom, you're going to have common log 11. Is everybody with me? And we still have, after we do that, we still have to divide it by 5. So we're actually going to have to do this on a calculator. So on the calculator, you're going to do common log 33 divided by common log 11. And if you take a look at the calculator, that's what I did right here. I did common log 33 divided by common log 11, and then I hit equal, and I got this decimal answer. Okay? So that's still not my final answer. What I have to do now is still divide by 5. So on my calculator, all I would have to do is hit the division button and then by 5, and that'll simply divide that number right there, by 5, and it'll give me my final answer. So if I did do that, hit divided by 5, I'd get the answer x equals 0.29163. And you know what? We probably should not write equal because it is an approximation. So we should put these little approximation symbols. And that would be your answer to number 7. What do you guys think? Let's try the last one, number 8. So you guys realize that it's not that bad. Number 8, you want to solve for x. X is in an exponent position. It's right here. So you want to get everything, want to get rid of everything except for that x. So what's the easiest thing to do? Subtract 1 to get rid of that plus 1 right off the bat. So you're going to have a 5 on this side now. And on the left side, you're still going to have the 1/3. You're still going to have the 6. Let me erase this. You're still going to have the power of negative 4x, right? So we still have this equation right here. And now we want to get rid of more things. I want to get rid of the 1/3 next. How do I get rid of the 1/3? Multiply it by 3, that way it cancels out. What I do to one side, I do to the other side. I will now have 6 to the power of negative 4x equals 15. Now what's my final step on solving for x? How do I get that x down? It's not even my final step, but it's close to my final step. I'm going to apply a log base 6 on both sides. So a log base 6 here, and also a log base 6 over here. That's really sloppy. I'm going to rewrite it right now. The log base 6 of 6 cancels. I have a new equation that says negative 4x equals log base 6 of 15. Final step to get x by itself would be what? Divide by negative 4, and we're going to divide this by negative 4. And we end up with the same situation as before. We already know the answer. The answer is x equals this stuff right here. However, if we want a decimal approximation for the actual value of x, we're going to have to use a change of base formula. So I want to put an arrow, and I want to do a fraction up here. And you could use the common log button or the ln button. I want to go with ln. ln of 15 over ln of 6. And then at the very end, after I get that answer, I'm going to have to divide that answer by negative 4. And that's all done on the calculator. So when you're working on the top, the ln of 15, now you could use common log, whatever you want. You could use the common log button right here or the ln button. Since we used the common log on the last one, I decided to use the ln button on this one. So when you go ln of 15 divided by ln of 6, make sure you close parentheses, because it's going to, when you hit the ln button, it's going to open up parentheses, put 15, close it, then hit the divided by, and then ln of 6, close parentheses, hit equals, you're going to get a decimal. So you have the answer to this blue one, but then you just go and hit the division button on your calculator straight from it, and it'll appear as answer divided by -4, because we're doing the divided by -4 over here. Then it'll give you your final answer of x being approximately -0.3778. So that's what we're going to write as the final answer. X is approximately -0.3778. And that's our final answer there. I hope we get it. I hope it makes sense. That's it.